Okay, hello again. So I am making a video from today's lesson. This is um, Unit 7 Progress Check. This will contain both Part A and Part B, with and without a calculator, I think. And some of the classes today, we got through most of this. Not all of it, definitely not all of it. But also, one of the reasons I'm doing this is because there are a lot of people who are out today, and I want to use this as an opportunity to kind of preview or get more ready for the test that's on Tuesday. All right, so I'm about to start. If your class has done whatever I'm doing right now, you could just fast forward to the parts that we did not do in class. But I'll start from the beginning. All right, let's see. So let's start. So a large vat. Okay, read through that. Oh well, yeah, yeah. So you're given a situation, life situation. A water's pouring into a vat, which is just a large container, and at the same time, water is pouring out, and the amount of salt, right? The amount of salt is changing over time because you're pouring in, higher concentration and flowing out as a mixture. So it's nice to understand this, but ultimately this is what you want to focus on. You're given a differential equation, and you're given a right there a time to go zero. That is a what? That's a like initial condition. The initial condition does not mean that it's at time equals zero, although it's always nice to have time equals zero. That's your starting amount. Actually, let me fast forward this. I don't like this song. Okay. All right. So let's start. Right, an equation for the line tangent of this, and so the two parts. We're gonna write a line tangent, and then use the tangent line to approximate the number of pounds. So the moment you see this, the line tangent, or approximate, using the line tangent, you should be thinking two things. You need a point, and you need a slope to get the equation of a tangent line. So m equals, I'm going to write this as a guide for me and for yourself. Now the point is relatively easy. Sometimes without the word problem, sometimes they'll just give you a point outright. But in this case, they were in this way, the initial condition is the point. So this is when t equals 10. This is the output. So this is 10. Oh, right, this is 10, and the output is 50. Well, that's a point, x comma y. Now, what's m? How do I get m? The slope. Well, the slope is really gotten from the derivative. The derivative is the instantaneous slope, or the slope of tangent line. So by plugging these values, t equals 10. Uh, oh, okay. Notice there is no t to plug in here. Just literally plug in um, that. This is this is 50. Right? They told you outright, right? There is 50. That's your letter A. So the slope there, so let's actually do this, A prime, I'm going to abbreviate it like this. 6 minus 0.02, I'm going to have to do this. I don't remember, this is with or without a calculator, but it doesn't matter. I think numbers are easy enough. So 50 in here, that's your A, or output. And this is, move the decimal point twice, so this is 5, right? No, what am I saying? 5? It's 1, right? That's 5. Yeah, that's 1. So you move the decimal point, one's over here, and so that's over here, and so 0.2 times 5 is 1. So this is 6 minus 1 equals 5. That's what I meant, 5. Okay, 5 right here. So now how do I get the equation of a line that's tangent? So this is y minus 50 equals, the slope is 5, x minus, well, it's 10, right? That's the x 10. Okay, so this would be enough for this part. But since they're going to be asking about using this tangent line to approximate, I'm going to solve for letter y. So the y, by basically bringing this over, plus 50 to this side, and it's gone from here. right? So you add 50 to both sides. So this is your equation of a line, y equals, do not open the parentheses, do not simplify that to be y equals mx plus b format. But now we're going to plug in this, t equals 12 in here. And so my y value will be approximately, do not put an equal sign, my answer here will be approximately 5, because this is an approximation, technique. So this is 12, 12 minus 10, plus 50. Now, technically, what's nice, you can literally walk away from this and say, I'm done, because you don't have to simplify this for the purposes on the AP FRQ test. But for our purposes, we're going to multiply this out just to see what this is. Clearly, that's 2. 2 times 5 is 210. So this whole thing is 60. So my y will be approximately 60. Now I could actually call this letter A, right? Because this is your A amount of salt. So that you could say A of whatever, like 12 is approximately 60. And the units here are number of pounds of salt. So you cannot even be more complete, LBS. I don't think the units will make a difference whether you put them in this case, but it's a word problem, so it's always helps to think of it. This is my final answer, but I think you would still get credit if you just leave it like this. All right, that's 2 points, right? So what's nice about this, it tells you what the point award is. So 2 points for that. Next one. Okay. Same setup, same. So the part B, show that. Okay, show that. That's a technique where you don't have to create anything yourself. You're literally, they told you what the solution is. You just have to. Oh. Okay, sorry, I got distracted. Okay. So you just have to take a derivative of this to verify that you're going to get this, right? So we're going to take a derivative of this in a second, and are we going to get this? But along the way, they're also saying it has to satisfy the differential. Has the initial condition is this? Well, let's do that one first, because that's probably quicker. So the initial condition, they're saying plug 10 in here into your letter A in here, and see if you get 50. Well, you are going to get 50. It's just literally you have to demonstrate it. So A is this. So A of 10 will be 300 minus 250. E, just let's be careful not to lose anything here. 0.2 minus 0.02 to the what, this is 10, right? And let's simplify that. So this part is, well, this is 0.2, right? So this 0.2 minus 0.2, this can, you can rewrite this as 300 minus 250 e to 0, right? Like it's 0.2 minus 0.2. Well, this becomes what? This is simply equals to 1. So this really is 300 minus 250 is 50. And that's what we're getting. We are getting this. Okay. That's a verification of the initial condition. Now, the second part, or the first part, whichever, a little more challenging, because you actually have to take a derivative of this to verify that we are going to get the initial this. We're going to get this. So let's start. A prime of t equals, take a derivative of this, right, of this. Well, hopefully, and by the way, all of this, of course, you should, like look at the problem, pause it before watching my work. You really should think about it and see if you can do it yourself. You should use my work only for verification purposes, or if you're like truly stuck, you have no idea where to go. So like, all right, that could be very helpful. All right, so anyway, so taking a derivative, obviously the derivative of 300 is 0. It's constant, so it goes away. The derivative of that becomes an exponential right here. Well, the exponential is negative 250, and the the derivative of the e part, what comes back as itself. So I'm just going to rewrite everything here, minus 0.02t, and multiplied by the derivative of the exponent. Well, what's the derivative of this? Again, that's a constant. That's going to go away. And the derivative of that is negative 0.02, right? Like it's right from here, just straightforward power. Okay. All right. Well, how does this look like this? Okay. Now, first of all, we could let's combine this and this. Let's just combine that just for. Um, Actually, I mean, there's more than one technique. Let's see if that's gonna be. So, um, yeah, let's see where that leads. Um, okay, because I'm tempted to actually, like, sorry, let me kind of refocus. So this, it has to equal to this. Um, well, okay, I see what this is. Let's actually write this out over here, because they were like saying whatever we get here must equal to this, but because the way the differential equation is written in terms of the original a, and this is a, I'm gonna rewrite this down here. So according to a dA dt equals 6 minus zero point zero 0.02, and letter A represents this whole function again. So I'm going to rewrite this right here. So this is 300. I'm going to use a different color. So 300, that minus 250 e point 0.2 minus 0.02 t, and that's my letter A. All of this is letter A. Oh, that right there. And all I have to do here is open up the parentheses and see is just going to get me to the same as what I got manually. So let's open up the parentheses. Uh, this times this times this. So I have a 6 minus this part times here. Moving the decimal point once, twice. That's 3 times moving the decimal once, twice. So this is, well, this is 6, right? Like literally, this times this is 6. And that's nice because I see that's gonna cancel out. Now the rest of it, the second part is this. Frankly, I don't have to do anything. I do not have to multiply things out here because this is minus 0.02, which is that, times this, minus 250 e point 2 minus 0.02 t. Well, that's exactly what we got here. We did it, you know, I don't know, manual derivative right here, and here we just distributed, you know, what what stands for, and this equals to this because 6 is canceled out, and the rest of it is the same. In fact, you can literally rewrite that as a equals to that. Okay, so I don't know, equals. Well, I'll just do that. Okay. All right, and that is worth 3 points. Yeah, there was you know, decent amount of work here, you know, but you know, anytime you have a problem where it says show that, like you don't have to do the manual integration here to get this. You're not solving it. They told you what the solution is. You just have to demonstrate that if you take a derivative of this, you are gonna get what this was. All right, next. I'll jump to the next one. Okay. All right, this is worth 4 points. That seems like a lot of, you know, a lot of points. So like here we go. But okay, I remember this one. So this is part C, right? Part C. Same setup as you're reading this. All right, the flow of the solution in the vat is stopped and the solution is drained. the depth of the solution of that is modeled by the. So what happens? Whatever happened here, whatever happens, it pretty much stops. It ceases to exist. Uh, the idea here is, yeah, at a certain point, you have solution filled up to whatever level you have, and then it stops at a, and the solution is being, the liquid is being drained. So I'm kind of like showing you it's drained out according to this differential equation. Well, what is this? This is really not a volume differential equation. This is the height of your water level. Well, clearly, as this is being drained, your water level will just drop down and so forth. And at what rate? At this rate. This is the rate that H, this is H, is changing. DH. Okay, so let's write this out over here. So DH dt. I'm just gonna write this out so that it's little, So negative K square root of H. Now, I know in class some of you were tempted to right away look like, oh, that's an exponential, and some of you literally did this. You're like, H must equal to, and please, well, right now don't write this down, but this is what some people kind of wrote. K is this K, and the T. You can't do that because this, I mean, you could have done this if this wasn't here. If this wasn't here, you're absolutely right. That's based on our lesson yesterday or the day before. That would be where it is directly proportional to the amount itself, to the h font, to the height. The trouble is, this is not that because of this root sign. It's not it's proportional to the square root of h. So you can't do this. This is definitely, you can't do that. So let's erase this. Understand why we can't use that shortcut. We have to do the long, in other words, separation of variables. So we'll do that in a second. But also along the way, let me just kind of point out what you have here. What is this right here? So the idea here is, if you're stuck, at least you should write something on the side, pull out some information. It might jog your memories, like what do I do here? You can't just like stare at it and say, oh, I don't know what to do here. So I rewrote that. I mean, that in itself does not really work. But over here, I'm going to say when t equals 0, this is 16. So, okay, I'm going to write this as my water. In fact, it's an initial condition at time 0. But what about the second part over here? 4 meters at, well, that still could be considered initial condition, but it's really not at time 0. This is at 30 and 4 over here. So we basically have two pieces of information that we're going to use. I'm sure we're going to use this in a couple of seconds. Also, I want to point out, really, really important, that as you read through these problems, you want to make sure that your units are correct. As an example, if this was in, like, t was in hours, but it is in minutes, so it's really nice that these are consistent, minutes and minutes. But this could be a potential trap. What, like, let's say if this was in hours, meanwhile this is in minutes. That means this is not 30 that you want to use, but what? Half hour. Like the 0 is still 0. 0 minutes or 0 hours is still 0. But this could have been a trap, and you have to be careful. Because 30 minutes, if this was given, if the initial t was in hours, you have to make sure that they're consistent. But in this case, that's nice that, it's not a trap. You know, I don't know if that's too loud for the media. I like it, but all right, let's continue. So what do I have here? This and this. Yeah, sorry. Let's pay. So what's the technique? Oh, separate variables. How do I separate variables? T. I don't want to say clearly, but yeah, this dt will come up, this way, and this will go down across the equal sign. So this is going to be dh divided by square root of h equals negative k times dt. t. Now, okay, continue. I'm going to rewrite this as h to negative 1/2 power because ultimately you know that this is going to be a power rule. And there's a dh. We are going to integrate, right? So this is all integration. Well, once we separated the variables, okay. Now I'm going to kind of power through this. This is an integration, a basic integration. So you add one to that. So this is h to 1/2 power divided by 1/2, which is effectively that, equals negative k t plus c. Don't forget that plus c. Okay, now what? Well, we're going to use one of these conditions, and the easier one is clearly this one with a 0 in here. It's really nice. You plug 0 in here. You're going to get to solve for letter C. So plug in 0 in here, what are you going to get? So go ahead and do that. 0 in here, and 16, this is your h, so kind of in here. So 2 times square root of 16, which is 4. So 2 times 4 equals k times 0, which is 0, plus c. So clearly, I'll do it on the side. C must equal to 8. Okay, so I'm going to erase, well, you know what? I'm going to just erase this part. Right, we don't, that was just arithmetic. So my function is right now, as far, I don't know the value of k. I'll solve that solve for that in a second. But right now this is 2 times and h. So I'm going to use the second point here, the h. This is h. It's 4. 4 is square rooted. So it's so I'm going to write 4 square rooted. But then I'll obviously do this mentally. Negative k times, well, what's t value? T is 30. And plus, this is 8. Right, we found c to be 8. Solving for letter k, well, let's simplify that. This is what? This is 2. 2 times 2 is 4. 4, 4 minus 8 divided by negative 30 equals, let's see what that is. This is what? 4. The negatives, sorry, negative 4 over negative 30 equals 2 over 15, positive 2 over. So k value equals 2 over 15. I'm going to erase this just because I'm going to rewrite it down here. Or, on paper, I would just continue here. So let's actually continue right here. So let's not erase anything. So what do I have here? So it's 2 times square root of h equals, well, negative k is this, so negative 2 over 15. All I'm doing is I'm, substituting the values that we found for these two unknowns, and plus 8. Okay, and yeah, I'll make sure I didn't lose anything. And now we want to solve for letter H because they're ultimately asking what is right, what is that, right? So we can't leave it like this because right now there's, because of the square root and that too. All right, let's divide both sides by 2. Divide that by 2. Divide, so this becomes simply 1, and this becomes a 4, right? Okay, 4. And of course now you square both sides. So to get h will equal to, I'll just show this on this, kind of both sides. And when I say both sides, make sure you don't do this individually. Both sides as the whole. Put parentheses and square, and just kind of simply just clean up a little bit. This really is what's on the inside. Looks like negative 1 over 15, which is just t over 15, and then plus 4 and squared. Uh, and that's it. Yeah, that's it. See if there's anything to point out here that you could be, not that you, for FRQs, you definitely do not need to rewrite this as a simple as a different version. But I'm just going to rewrite that in case this is a multiple choice. It could also be written simply as 4 minus t over 15 and squared. Okay, same thing, just position. All right. Next. All right. So that was C. Next. Oh, and that. Oh, okay. And that that problem is now. I know on the handout I had today, there were other problems on the front, which we'll get to later on. Those are like add-ons. They were really not part of the initial FRQ from from progress checks. All right, let me jump to a next slide or next down here. So it's a different, right? So progress checks. Oh no, this is, which one is this? Yeah, this is the one we just did, right? So let me kind of go back to the beginning, right? Uh, where we're right here. So we're doing this one. Yeah. So this is FRQ Part B, right? This is Part B. Is it still without a calculator? I think it is. Yeah, I don't remember. But it doesn't matter. I mean, this definitely not in this case. You don't need a calculator. Anyway, on the output schedule for slow field. So given this, and this is a really easy one. I don't know. Like we did this in class, and I didn't really do it, but most everybody pretty much had it correct. Um, so what's nice about this, it's a product. So if x or y, either one of them is zero, this is going to be a horizontal slope. In other words, slope is zero. So when along the x-axis, this is kind of like these little quick tick marks, or along the y-axis. And so those are done pretty much right away. Now the other ones, you actually, you have to do a little bit of, put some thought into it. This is 1, comma 1, right? So put a 1, comma 1 in here. So this is going to be, positive 1. So it's kind of like this. Just, approximately 1. All right. Over here, this is going to be, well, this is a 1 comma negative 1, right? That's the point. So if you put negative 1 into the letter y, this is a negative, right? Negative 1 to the third is negative, but so this is going to be a negative 1, kind of like this. And doing the other ones, just as well. So this is a negative 1, positive 1, so negative 1 over here. This feels like it's this, right? Because pot. And over here, they're both negative 1, comma negative 1. Plugging that in will be negative 1 times negative 1 is positive 1. So kind of like this. So there's your slope field, right? Okay, at the 9 points indicated. All right, next. That was, and that's only, oh, that's actually more than I thought. That should be like 1 point. But, that's nice, 2 points. All right, next. Consider this a differential, same differential equation. Oh, right, same problem, of course. Find the second derivative in terms of x and y. Okay, so you were given the first derivative. It was just have to take a derivative of that to get the second derivative. Now, what's different about taking a derivative of this? Let's remember, and this skill goes way back. Like I don't know which chapter 3, I guess, or unit 3. This is implicit differentiation because you have this for you both x and y in the same operation. You're not solving for y by itself. You're definitely not doing that. Anyway, so let's take a derivative of that. So I'm going to write y double prime just so I don't have to rewrite this. And take a derivative of this. What's a product rule? So first, derivative of the first function, which is x1 times y to the third plus x times, what's the derivative of y cubed? Well, it's 3y squared times dy dx. Do not forget that part. Now, where are we going to get that? Well, that is exactly what this is, right? So we're just going to rewrite that. So this is, because it says in terms of x and y. You can't leave it like this because this is not in terms of x and y. So it's just one quick rewrite. So this is y cubed, right? Y cubed plus x. Well, I'm going to put a 3 in front, not 3, x y squared times, and this is just x times y cubed. Technically, you could leave it like this, but I think it's nice manners to clean up. So y to the third, right? Y to the third plus 3, and your x's are right here. So x times x is x squared times, and then y to the, let me do a different color, y's. So this is looks like 5y to the fifth power. Okay, and that should give me up to this point. I got up to this point, right? So I'm done here. And it's 2 points. So I guess I'm worth. I mean, this is worth. Well, not I'm worth, but this is worth 1 point, which is a little surprising. I thought it should be maybe 2 points, but only the whole problem is worth only 2 points. All right, second part. Determine the concavity. Remember what concavity has to do with. Uh, concavity of the original concavity of the original y, right? Of the solution curve, right? Of the solution curve, because y is the solution to this differential equation. Anyway, so it has to do with with the sign of it. Plot if the second derivative is positive, it's the concavity is this. It's if second derivative is negative, concavity is the other thing. So let's actually figure out in the fourth quadrant, right here. Well, in the fourth quadrant, both x, well, no, x is positive, right? I'm just going to write this, and y is negative, right? So, in other words, it's below the x-axis. You could also write it, if this is on an AP test, I don't know if they like that notation, but you could say this is greater than 0, this is less than 0, right? That's positive, that's negative. Okay. So we're just gonna I don't want to say random, but just kind of like a test point. You have to plug it in here to see what we're gonna get. So the second derivative, I'm just gonna cheat and write y double prime equals in that quadrant. Well, this is gonna be a positive, so y to the third. Sorry, I misspoke. The y to the third, if it's a negative number, like put -1 for all I care. I don't know. Put negative number. This is going to be a negative number plus, and let's put in a uh, like whatever x is a positive number, so 3 times a positive number multiplied by a negative number. So what are we going to get here? Well, we're going to get a negative here, right? So this is a negative number plus a negative number. So clearly, it's a negative number. Now, I don't know if I like for the AP would I leave this notation. This is really just to make sense of it. But ultimately, on the AP test, I would write, since this is the case, y double prime is less than 0 because it's in fourth quadrant. Therefore, since the second derivative is this, it is, y is, well, remember, is it concave up or concave down? So it is, if it's negative, it is concave down, like this. So concave down. Okay, and you can leave it like this, concave down. And here's your reason, right? Here's the reason for in the fourth quadrant. Okay, so yeah, that should give you full credit. And it's only what, 2 points? Yeah. Okay. All right, next. Same problem. So given the particular solution, find the particular solution given the differential equation. So they're giving you a point initial condition. So on the side, I'm going to write 2 comma -1. You don't need to write it, but it's just kind of explicitly, written right there. And we are doing what? Particular solution? Well, just by looking at this, you can do what here? It's 5 points. That's a lot. It's going to be a lot of work. Okay. So I was just about to say, separate the variables, take an integration. So yeah, that's why it's worth 5 points. A lot of steps. So let's just separate the variables over here. Dx is going this side, the y. So this is going to be dy over y cubed. Now I'm going to write it immediately, like just simplify this as y to -3 power dy, right? And equals, well, what's on this side is just x times dx. And obviously, it should be obvious, I'm going to integrate on both sides. Actually, there's a third side, but it's really the same thing as this. It's just to rewrite. So power rule, right? It's just straightforward power rule. Add 1 to this side, y, add 1 becomes -2, divide by -2, okay, equals power rule to here, x squared divided by 2 plus c. Okay, plus c. We're gonna not forget that. So now we're gonna find the c by plugging values in here and figure out what c is. So x, this is y. So the y is -2, so I'm going to do this on the side. -2, what am I saying? -2, it's -1 right there. -1 right, to the -2 power, and with a minus, like -2 in front, so put a minus kind of like this, equals the 2 in here, well, I'm just going to write it for 1 so that I don't lose any, plus c. Let's simplify this, and this is without a calculator. Clearly, you could do this. Um, this is -1 over 8, right? Oh, what am I saying? 8, 4, right? So the two, the negative make it come down here, but it's just a 1, right? This is a 1. So this is what this. It's 1/2. Did I say one? I don't know what I just said, but yeah, this is 1. Okay. All right. Equals, well, what's on the side? This is a 4 divided by 2. That's a 2 plus c. Oof. What? Why am I getting stupid numbers? Bad numbers. Uh, Let me make sure I didn't do anything, wrong. So the x is in here, so the x is squared, that's 4 divided by 2, that's correct. And 1 in here, this is, without the negative, it's 1, but divided by, so yeah, no, I'm good. I'm okay. So c must equal to, oh, -2.5. Right? So yeah, -2.5, or what's not? Yeah, you can leave it like this, or -5/2. Oh God, okay. So, I don't know why they would do that to us. All right, assuming that I did it correctly. So now that's your letter C, but that we're not done. We're not done with. Well, let's simplify. Let's rewrite this first of all, and multiply everything by -2, right? So y -2 here equals multiplying both sides. So this becomes, when this comes over here, this becomes -2. I'm gonna write this just so that I don't lose anything accidentally, and then plus, well, plus -2, so I'm going to times 2 times, and what's the c value? That's why they did the c value is -5 over 2 here, which is nice. Okay, that's probably why they did with the simplification. So y squared, so this is just -1, so put a minus here, and this is a positive, and these guys cancel, it becomes +5. So this really is negative x squared plus 5. And the other side is just, oh, this is a little bit of a pain, yeah. So this really is 1 over y squared equals 5 minus x squared, right? Okay, all right, let's go with that. How do I solve for y? I mean, there's, just literally flip. You could think of this as like over 1 and just flip both of them. Or you could think of it as in terms of, again, I'm being distracted by, okay, I just want to, my wife, okay. So you could cross multiply, and this really becomes y squared equals 1 over 5 minus x squared, okay? And we're almost done. I promise, we're almost done. How do I get rid of the square? Square root on both sides, but that creates plus minus version. So we have to, identify which version we want based on the initial condition. And notice, yeah, I'm going to rewrite the initial condition over here. So yeah, I see. So this becomes y equals, and I'm going to write either a positive version of the big root or a negative version of the big root, right? Whatever's inside here, right? I mean, it is this, right? It is this. But whatever it comes out, you take a square root of any number for the AB for the AB uh, calc, this part is positive. This part is always going to be positive. This part is positive. Okay. And how we're going to get the negative, what was it? The point there was 2 comma 2 comma negative 1. How we're going to get negative on this side, negative 1, if we have, well, the only way of doing that is if we are using the negative version of it, right? The negative version of something, whatever comes out. So yeah, the answer is going to be the negative version. So I'm going to rewrite this as the final version. So y equals big root sign with a minus in front, and this is 1 over 5 minus x squared. Okay. And I think you can leave it like that. I don't think there's anything to be, embarrassed about. Like, no, this is good. Okay. As long as I didn't make any stupid mistakes, this is fine. Okay. Yeah, well, in other words, you don't have to rationalize this. This is fine. All right, let's see. That was that was what, worth a lot. 5 points. Yeah, and here's the whole thing, Yeah. Okay, next. So that was part C. Next. Okay, so second question number 2. Okay. So given this differential equation, that's pretty oh yeah, I remember, like, yeah, in class the handout that I gave out on some of them had a letter T here. So be careful. That was a typo. Yeah, because I had to manually at one point edit this. But anyway, so here is the dx. I mean, it's the dx. Here is a really complicated looking expression. So part A, portion of the slope field above, this above the differential equation is shown. So sketch the solution curve. So you go through these points. You literally go through the whatever. Yeah, they give you 2 points, one here and one here. So let's do the first one. So where is 0, 1? So 0, 1, 0, 1. It's right here. So if this is 0, 1, the solution curve going through the force field, the slope fields will kind of guide you. So like from here, it's saying no, stay flat the whole time. Okay, stay with the zero slope, and going backwards, it's the same thing. So the solution curve through this point is literally oh, okay, I need that. It's literally this line, right? So this is okay, it's a horizontal line. Okay, this would be like original y equals. Okay, all right. The second point, the more interesting point, which is this one right here. I'll use a different color. Let's say green. This one right here. So this is 0, 2 point. Yeah, just verify it is that. So let the slopes guide you, kind of, showing you go here. Now flatten out, and kind of like start pulling up. So kind of pull up. But when you get to this, it just starts to flatten out, and then very sharply turn down, and just kind of go like this. So, okay, there's my up to this point. Now over here, kind of going backwards, flatten out, and then do that. Okay, I don't know how to describe it. Just kind of, just go with the flow. Yeah, that's exactly what it feels like. These slope fields look like like some kind of turbulence in the water. In fact, if you are going to take Calc 3, which is multivariable calculus, these kind of water flows are very important. Um, it can indicate flux, it can indicate divergence, it can indicate all kinds of more advanced topics. Anyway, let's continue. Like part B here, right? The equation of the line tangent. Okay, line tangent. Oh, it's only 1 point. That's kind of that feels like a ripoff for any question for 1 point. Is it worth my time? All right, equation of a tangent line. Okay, line tangent. Okay, the solution curve. Um, I was gonna say, how are you supposed to get? No, they gave you this equation. All right, to get This is m. Remember, this is your slopes, and the point is, so you have a point 0, 0, comma 2.5, right? That's a point. And what's the m? What's the slope? M. Well, we're going to take these values, x comma y, and plug it in here to get the slope. So let's see. Y minus 1, so I'll do this m, which is my slope, which is, like plug it into the derivative um, formula, or function. So this is 2.5 minus 2, so 1.5. I'm going to write 1.5. X equals 0. Okay, 0, that's 0, that's 1. Okay, that's just 0. In fact, right, 0. This is going to be 0, and this is going to be 0, because 0. Well, what's cosine of what's inside here? Cosine of pi is -1, right? Like off the top of your head, you should be able to like give me that instantly. So I have 1.5, so obviously it's -1.5. Okay, that's the slope. And now the rest of it is pretty quick. So the equation of a tangent line, or line tangent, y minus, the point is 2.5 equals, the slope is -1.5. And this is x minus 0, which I can write it, or just without the minus 0. And you can leave it like this. This is, you don't have to simplify it. But although in this case it's always like, unless you if you especially if you have like OCD, and like, oh, I can't leave it like this. No, I'm gonna rewrite it. Y equals -1.5 x plus 2.5. Okay, there is my equation of a line tangent. And Uh, I was gonna say, is it accurate looking? Yeah, for sure, I'm getting a negative. Well, let me do a different color. I'm getting a negative slope here for sure. Yeah, is it 1.5? I don't know. I don't. Like I hope I didn't do anything stupid here, but I'm pretty sure I didn't. Okay, so I'll say it is what it is. And of course, yeah, 2.5 is the y-intercept. Yeah, so I'm looking okay. All right, next, part C. Part C. Ooh, 6 points. Lots and lots of steps. Find a particular solution going through this point. So again, this is the point of 0, comma 2.5. So we'll do this one kind of on the side. Find a particular solution. In other words, this is clearly, well, I should say clearly, it's separation of variables, right? Like that's the only technique that we're familiar with. So this I'm going to separate right away. dy divided by y minus 1. Now the dx comes up, and this really, so I'm actually gonna, I already see what the steps will be in a second. So this I'm gonna rewrite as this cosine of x squared plus 2x plus pi in, and I'm just gonna stick this x plus 1 behind. You'll see why in a second, because I'm already envisioning where this is going. And of course there's a dx that comes up, right? So there's a dx. And of course you integrate both sides. Okay. Now this side, I don't want to say that. Well, no, this side is, it's actually pretty easy. This side we're going to talk about in a second, but this is simply ln of absolute value of y minus 1, right? Like that should be instant recognition at this point. It would have been nice, but really not essential if that minus 1 wasn't there. It would be just ln of absolute value of y, but that's part of it. This is like a miniature baby u sub. Now, speaking of u sub, on this side, I see clearly this is a u sub problem, right? Uh, this is going to be my u, so I'm going to write u on the side here, x squared plus 2x plus pi. And I don't know if you saw that instantly or not, but it's a variation of a u sub. I mean, so du will equal to 2x plus 2. And of course that goes away. and in parentheses and dx, because that's, you know, that's where it is. All right. How's this compared to this? Well, this is twice as big. Like, yeah, this is 2x plus 2, and this is x plus 1. So this must have been 2. Just kind of factor out x plus 1 dx. And this is a du on this side. And of course, we're going to divide both sides by 2. And this way now it's a perfect match. This is this. You know, I should not have to explain this part. This should be, you know, this is unit what, unit 6, way back. Anyway, so we're not recap. Let's continue. Um, this is cosine, so integral of cosine of u times this part is this, so this is du divided by 2, but I'm going to push the 1/2 to the front. And we've done this, you know, many times, this kind of problem. I'm going to show, I'm going to do my work here so I can rewrite nice and clean for as an equation. So this is 1/2, right, 1/2. Well, what's the antiderivative of cosine? What function you took a derivative of? And you got cosine, it was sine of u plus c, right? There's a plus c there, okay? And don't worry about those, like, oh, does this 1/2 apply to c? Well, we're just going to solve for that c and plug it in here to find it, to find whatever this right here is, okay? Uh, with you know, at this point we have to unsubstitute. This is not one of those where you change the limits of integration, because this is not a definite integral. We don't have the actual, you know, numbers here, right? This is, anyway, so this really is ln of y minus 1 absolute value equals, this is 1/2 sine of what? Of this whole thing. Of, okay, x squared plus 2x plus pi. Okay. And that's the, right there, right? U is this, right? U is just kind of, right? It's this. All right, and plus C. Now, how we're gonna have to solve, you know, plug this point and to find the value of C. Well, let's do it. So, uh, 2.5. So ln of y is 2.5. Well, 2.5 minus 1, that's just a positive. I don't need absolute value. 2.5 minus 1 is 1.5. Okay, that's all right. Well, whatever. Equals, on this side, 1/2 sine of, plug 0 in here. So 0 in here, sine, this is, you know, this is 0. This is 0. So you have sine of pi. Well, what sine of pi is 0. Okay, that's convenient. This, all of this is 0. So you have less plus c. So on the side, c must be ln of 1.5. Okay, I'm gonna put in parentheses because I just, yeah, I don't know. Well, that's a little unusual for letter C. I'm pretty sure I didn't do any mistakes. I mean, I'm confident. All right, so we're not quite done. But we already get a lot of points along the way. We integrated correctly. We got the letter C. You know, get the value of C. So chances are we at least got 3 points for this, for all of that, for separation of variables, taking the integrals properly, maybe even 4 points. You know, whatever. Even if, you know, at this point it's you know, well, we just have to continue to get all 6 points. So what is the original? What is not original? What is the solution? This is ln of y minus 1 absolute value. We still need absolute value, or do we? Well, I'm just gonna keep it on here for a second. All right, I'm pretty sure actually I don't need it because the value of y was a positive one here, so we should be okay. Okay, but let me just continue with this. So this is 1/2 sine of x squared plus 2x plus pi in parens plus ln of, and there's probably, I don't know how, it doesn't matter whether it could write this as 3 halves now that I think about it as 3 halves, or I'm just going to keep it as 1.5. Okay, 1.5. Okay. Um, how do I finish this? Oh, what am I? Yeah. That was silly. Exponentials to both sides to get rid of ln. So this is if you take exponential to this, kind of like this, to the whole thing. So, the ln and e will cancel. So I'm not even going to bother writing this. So this is absolute value y minus 1, absolute value. I'm pretty sure I could drop the absolute values, but nevertheless, I'm just going to keep it here. So this is an exponent. And the fact that I have an exponential to this whole thing, including that. Oh, I see why that. Okay, that's going to be nice. So this is, I'm going to separate this into two parts. This is exponential of ln of 1.5 times e to this whole thing. So this 1/2 sine of x squared plus 2x plus pi, kind of like this. Okay. And the c's already in core. This c, we solved for c. This c is in here. So, but what's nice about this, e and ln cancel out, and this really becomes, um, just 1.5 times this. And notice on this side, we're going to add 1 to both sides to get rid of that. Now, the question is, do we really need the absolute value for it? Well, this is always positive, this is always positive, and this is always, well, in this case, it's always positive because they told us that they want the positive version. That this is a plus. Yeah, the e to anything is positive, this is positive as well. So we don't need the absolute values. This is by adding 1 to both sides, y equals, this part is simply, they cancel, this is 1.5, e to this whole hideous thing, so 1/2 sine of x squared plus 2x plus pi, absolute, I mean not absolutely, close parenthesis, and then of course plus 1. The plus 1 came from here. All of that. This is my final answer. Right, my final answer. Okay. And hopefully I earned all 6 points because I think I deserve it. All right, let me see if there's anything else. Oh, right. These are the extras. Even though technically speaking, that was the end of the official uh, FRQ, progress checks. But to save paper, I added a couple of problems. All right, might as well do that because there are, it's valid questions for the test and also for the AP. All right, it just makes this video pretty long. Sorry. All right, so of the following, which are solutions to the differential equation? So you're given a differential equation, and it's a second order, and you have to just see which one or more than one fits. So this is really where, all right, second derivative. So you literally have to find for each one. This is you have to check every single one. This is one of those really not difficult, but just time consuming. Okay, so let's start. What's the first derivative of the first one? Well, this is exponential. This is pretty easy. It comes back as itself, 2t, and then times 2 in front, right? That's a first derivative. How about second derivative? Second derivative equals, well, I take a derivative of this. This comes back as itself, e 2t, and then times this. So this really becomes 4 here. I'm just going to write, this becomes 4, right? Because it just, hopefully, now we're going to plug things in here because I see that we're, and see if this fits, this differential equation. So the second derivative is this. Let me just do it. So it's 4e2t minus 5 times this first derivative. So it's 5 times 2e 2t, and then plus 6 of the original y, and this is the original y. So this is e 2t. And the question is this equal to 0? I could fit this in. Is it equal to 0? And looking at this, there's, these are all the same, right? It's like these are all, that says a common factor, all of them. So 4 of this minus, this is 10. So 4 of this minus 10 of the same thing plus 6 of the same thing equals to 0. Yeah, that's true. 4, yeah, they're all going to cancel. So yeah, this is true. This is true. Okay. Um, I'm going to erase. Oh, I think Lola doesn't like it. Sorry. There's a Amazon delivery. She does not like those. Oh, it's okay. It's okay. Yeah, she's a killer. Oh, okay. Oh, that delivery person's about to run from the barking. All right. So sorry. Let me erase this part. So this was correct. All right. Let's erase all this. Next. So we'll plug in this. All right. The night is getting really long. This is pretty late. Okay. So let's. So this is my. Well, we already solved that. So this is. All right. First derivative. So let's do this quick. This is 9e3t. Y double prime is 27 e3t. 3t, right? It's 27. Yeah. And now let's start plugging back in here. So the y double prime is this 27 e, and I see that they're all going to be e3t. That's nice. Okay. So, but I'm going to still write a 3t minus 5 of the first derivative. Well, minus 5 times 9. I'm going to write minus 5 this e3t, and then plus 6 of the original. The original had a 3 here, so 6 times 3 e3t. Yeah, they're all e3t, so you have 27 of them minus this is what, 45, and this is 18. And let's see if that going to cancel. Is that going to be 0? Because that's really what we're trying to hit. 27 plus 18 is 37, 45. Yeah, this is 40. This is 45 minus 45, and of course that's 0. So 0. So yeah, this one is also true. And I'm going to erase and pick up the piece. All right. Sine. Oh, I'm pretty sure. Oh, yeah, I see. Sine. This is going to be false. This is going to be false because the second derivative is going to turn sine into a cosine. Okay, the first derivative, sorry, so the original function and the second derivative may, come back to sine, but the one sine, but one derivative. All right, anyway, too much talking. So let's do the first derivative. Y prime is, this is a miniature u sub, so this is derivative sine is cosine. This is 6 cosine of 2t. Okay. Second derivative equals, uh, well, negative, so negative 12 sine of 2t, right? Negative sine. So yeah, hopefully it's clear. So this, just verify. Okay, yeah, and when you add them, when you string them together, so negative 12 sine 2t. They're all going to be 2t's, but it's the sine and cosine that's going to make a difference. Minus 5 times this. So 5 times this is 30, but this is cosine 2t, and I can stop right there. There's no way I'm going to cancel them. So this, and then of course plus 6, I mean, even though I just said I could stop, but plus 6 of the original y, which will be 6 times, this is 18, 18, but the problem is, and this is sine of 2t, this will never equal to 0, right? This will never equal to 0 because these are cosines and these are sines, so they will not cancel. All right, so the next one, I mean, the last one is false, so this is 1 and 2 only, 1 and 2 only, and there it is, 1 and 2 only. So yeah, they're easy, but they're like the ones that take a little longer than than they deserve. All right. Lastly, a vehicle moves along a straight road. Vehicle's position is given by this function. So this is a position function where t, so seconds. There's no special no initial conditions. So this is really just a rewrite, right? A differential equation describes this relationship. Okay. Where k is a positive constant. All right, so during the first 10 seconds, the vehicle's acceleration. So acceleration means acceleration. Well, of t, I can just write a. But remember what acceleration is relative to the position. This is the f, this is f function. So this is f, like a position, f double prime. Okay. And it's equal, the word equal is directly proportional. So it's a k directly proportional to the of cube root of t, of time. So cube root of t, so that, but it continues, and this is still, yeah, I mean, this is continuation of proportional. This is inversely proportional to the velocity. Well, the word inversely proportional means you're going to do this, 1 divided by something. So it's inversely proportional to the velocity, so I'm going to write this. Okay, for now. I mean, I'm going to rewrite this in a second. So well, now I'm going to, so f double prime, because they're asking for differential equation. They don't want to, I don't want to see a and v and that kind of thing. Everything is going to be in terms of the original function and its derivatives. So f double prime equals k times cube root of t divided by, well, v is what? V is f prime, because that's the velocity is a derivative of the position, but the position we're using the letter f. So there's f prime. So this is my answer. And you can clean up. I mean, no, I was going to say clean up, but no, this is already that. Uh, yeah, that's the way that's the way to read that. Direct proportion is a multiplication. This is directly proportional, and inverse proportional is the divide by. Okay, and I think I'm done. Yeah, I think I'm done. Oh my god, this was a much longer video than I anticipated. That stuff takes time. Oh, stuff takes time. All right, I will see. Oh, let me see. Where is it? Let's stop it. Okay, I will see you whenever. Oh, why is that audio on one side only? Okay, okay. Discord. No, stop.